This video is going to be talking about regioselectivity of E2 reactions. So, in some cases, there are going to be two types of beta hydrogens that we can eliminate. So this video, we're going to be talking about which beta hydrogen is going to eliminate and what is going to be the favored product. So you can see here, here's the alpha carbon, and we have bromine as the leaving group. And then we have two different types of beta hydrogens. And you can see if we were to eliminate this beta hydrogen, it would make a more substituted double bond, or if we eliminated this beta hydrogen, it would make a less substituted double bond. So which product is favored? It depends. These two types of products that can be formed are called Hofmann or Zaitsev. Hofmann is going to be the less substituted product, and then Zaitsev is always going to be the more substituted product. So how do we know which one is favored? It depends on the base. Small bases are going to favor Zaitsev, or the more substituted, because it can access that it can access the beta hydrogens that are more sterically hindered. But if you have a very large base, that is going to favor Hofmann because they can't get to those more sterically hindered hydrogens. They can only get to the less sterically hindered ones, which would give you a less substituted product. So here's some examples of sterically hindered bases, or you can just say big bases. One that's used a ton is going to be potassium tert-butoxide, or TBUOK, diisopropylamine, or triethylamine, which is also shortened to TEA. So now we're going to talk about the process on how to make this decision. So step one is to identify the different beta hydrogens. So you can see in the example we have here, we have a beta hydrogen on this carbon, and then we have a beta hydrogen on this carbon. And those are going to give you two different products. So step two is to draw out both of those products. So you can see here we have the less substituted, and then here we have the more substituted. And either way that you eliminate this is going to be the exact same. So the next step is to determine whether the base is big or little. So in this case, we have NaOMe, or sodium methoxide, and that is going to be considered a little base because it's not sterically hindered. You can see that this oxygen right here, which is going to act as the base to take up that hydrogen, only has one group coming off of it. So it is relatively small, and it can get those more sterically hindered hydrogens. So now you have to make a choice, and in this case, because it is a little base, the major product is going to be Zaitsev, or the more substituted. So just to clarify, remember if we draw a line through these double bonds, the minor or the Hofmann product only has two things coming off of it, and then this one has 1, 2, 3 things coming off of it. So that's what I mean by the more substituted product. So this would be Zaitsev as the major product. So go ahead and pause the video and use those steps we just talked about and see if you can figure out what would be the major and minor products of these two. All right, for the first one, we have tert-butoxide, which is, as we said earlier, a very large base. So in this case, the major product is going to be the less sterically hindered product. And then the minor product is going to be the more substituted product. For the second one here, we have sodium hydroxide, which again is a small base. This oxygen is going to act as the base that takes up one of the hydrogens. And it is not sterically hindered, it just has an oxygen coming off of it. So that's why in this case, the Zaitsev would be the major product. I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.